good day. You are watching How Things Work. Ever wondered how pilots gather data in flying the aircraft you're in? The wait is over. In today's segment, you will be enlightened by how pilots are skilled to understand those instruments that they are using.
There are 6 traditional flight instruments in most aircraft cockpits. Many of these instruments have taken on a modern appearance over time, but even technology-advanced aircraft have traditional instruments to use as backups in case the primary system fails.
The following instruments made up of what's called the six-pack. In traditional cockpit, where 3 instruments are stacked on top of 3 other instruments. These 6 basic flight instruments are the main source of cockpit flight information for pilots and are divided into 2 categories: the pitot-static instruments and the gyroscopic instruments.
Let us start with the pitot-static instrument. The first instrument that belongs to the pitot-static instrument is the airspeed indicator. The airspeed indicator tells the pilot the indicated airspeed in knots. The airspeed is sometimes also depicted in true airspeed, which is a valuable information for flight planning. In a nutshell, the airspeed indicator works by comparing ram air pressure from the pitot tube to the static air pressure from one or more static ports. The diaphragm inside the instrument casing measures the pressure differentials and depicts it on an instrument pointer. Airspeed indicators are also color-coded, so the pilot can easily identify ranges such as normal operating range, flap operating range, and caution operating range. Minimum and maximum speeds, as well as other important speeds known as V-speed, are marked as well.
Next is the altimeter. The altimeter reflects the aircraft's vertical height above MSM, or mean sea level, corrected for outside air pressure. The pilot sets the appropriate pressure setting, and the altimeter will depict the corresponding altitude above MSM. The altimeter works similar to a basic barometer, by comparing the static pressure inside the facile anaeroid capsule to the expanding or contracting pressure surrounding it. When the airplane ascends or descends, the air pressure will decrease or increase, respectively. This outside air pressure is constantly being compared to the pressure inside the anaeroid capsule, and with the help of the linkage of a pointer, the altitude is displayed on the cockpit instrument. Last but not the least, in the pitot-static group is the vertical speed indicator. The vertical speed indicator is the rate of aircraft's climb or descent, usually depicted in the feet per minute. On the vertical speed indicator, in level flight, the VSI needle points to 0 feet. The VSI works by measuring and comparing the static pressure inside of the expandable capsule to the metered static pressure outside of the capsule. The pressure inside the capsule changes very quickly as the plane climbs or descends, while the pressure outside of the capsule changes very slowly due to metered leap. During climbs and descents, the capsule compresses or expands. Respectively, the pressure difference is measured and linked to the pointer, where it's depicted on the instrument face. The VSI is valuable in determining if the airplane is climbing or descending. At the rate of climb or descent, there can be a slight lag in information depicted on the VSI if the aircraft is maneuvered abruptly, and turbulence and indication of can be slightly erratic.
And now, let us move on to the gyroscopic instruments, starting with attitude indicator. The attitude indicator is possibly the most important instrument for pilots. In one glance, a pilot can tell if the aircraft is climbing, descending, turning, or straight, and level. Amazing, right? Also, it gives a direct indication of changes to pitch, attitude, and bank. The attitude indicator consists of an artificial horizon that is a background for a miniature airplane. Wow, genius idea! The instrument is meant to depict the sky, usual blue in color, and the ground, typically brown, with a miniature airplane positioned on the artificial horizon, a white line, in level flight. In most cases, the miniature airplane is attached to the instrument viewing case, and it moves with the airplane. The artificial horizon sends movement from the gyroscope and remains suspended in relation to a self-erecting gyroscope, which holds its position in reference to the actual horizon. The gyroscope itself can be vacuum-driven or electric.
Next is the heading indicator, a basic tool for navigation. The heading indicator provides directional.
And that concludes our segment today for How Things Work. Thank you for listening and watching. Goodbye!